Welcome to the course on design of power electronic converters. So, we have been discussing IGBTs, we saw the basic terms of IGBTs, then we discussed the switching characteristics, then we further discussed the important notations and performance curves in datasheets. Now, let us take an example of an IGBT datasheet and let us look into it, what all things are provided. The datasheet I have chosen is by International Rectifiers, and this you can see here from the diagram itself that there is an anti-parallel diode provided in the IGBT. This is the picture of it. It uses this TO247 package. You can see these three legs are the three terminals of the IGBTs, and this is the part number of the IGBT. And then you can see the key ratings. It is a 1200 volt device, so it can block 1200 volt. IC continuous collector current rating is your 45 amperes at 100 degree C. Maximum junction temperature is 150 degree C, and typically this on state voltage drop between collector and emitter is 1.7 volt. And these are the key features of the IGBT, okay, that the manufacturer has given. Then what are the benefits and the different applications of the IGBT which are targeted by the manufacturer. Then further, these are your continuous collector current IC at 25 degrees C. You can see that is 85, whereas at 100 degrees C the same IC goes down to 45 amperes. Then the collector to emitter voltage, this we have already seen, is 1200 volt. Then I nominal, this I had discussed with you, this is given as 30 amperes. Then the pulsating current rating, maximum pulse current, that you can see is 90 amperes, much higher than this 45 ampere rating. Further important ratings that are given is your IF, the forward current rating of the diode. Diode continuous forward current is given as 85 at 25 degrees C and 45 as 100 degrees C. So, this matches with these two specifications what the IGBT can carry. Then gate to emitter voltage, so that maximum that is allowed is this your plus minus 30 volt. Then your this pulsating the diode current, what the diode can carry is given as 120 amperes. Then these are the maximum power dissipation limits at 25 degrees C and 100 degrees C. So, those are provided. Then junction temperature and storage temperature range, that is also given, and here your mounting torque and soldering temperature, those things are also provided by the manufacturer. Then further, these are your thermal resistances. So, your R theta JC junction to case, this is given, and here this is given in Celsius per watt. And your for the diode, because here there is the IGBT is also there and diode is also there. So, for junction to case for IGBT and junction to case for diode, this are going to be different here. Okay, so that is also provided. You can see here for diode it is higher. And then case to sink, because all of these IGBT and diode, these are inside one case. So, case to sink is going to be only one. So, that is also provided. The junction to ambient, that is also given over here. Then your breakdown voltage, this 1200 volt we have seen before. Then saturation voltage, you can see typical is 1.7 and maximum is 2 volt, and at what conditions they have made these measurements, they are also given. Okay, so, they change with these conditions. Then what is the gate to emitter threshold voltage? So, that is minimum is 3 volt and maximum is 6 volt. Further your forward transconductance, that is also provided, And collector to emitter leakage current, those things you can see it is given in microamperes, and the conditions are also provided here, and they vary significantly with your conditions. If this junction temperature goes to 150 degrees C, you can see that over here there is a significant increase in the leakage current. Then further you see this diode forward voltage drop, what is the typical and what is the maximum. Now you can compare this with your over here what you are getting. Okay, so here 2.1 is what you get at 150 degrees C, and here this you get 2.2. So this diode voltage drop, what you can see, is greater. So whenever the diode is going to conduct, the drop will be higher, because depending on the direction of the current, it is either your IGBT or the diode will be conducting. So this is your IGBT. So now if the direction of the current is downwards, so this IGBT is going to conduct, and if it is upward, it is the diode which is going to conduct. So which one conducts? So that decides whether this voltage drop is going to appear or this voltage drop is going to appear. Then gate to emitter leakage current, that also is provided in the by the manufacturer. Further, your switching characteristics. So QG, the total gate charge, and gate to emitter charge and gate to collector charge, those are given, these are given in nanocoulombs, and the conditions are also mentioned here. Then your turn on loss, turn off loss, and the total switching loss, these are also provided, and the conditions also you can see here, they are also given over here. Then turn on delay times, turn off delay times, rise times and fall times. So basically turn on times and turn off times in nanoseconds, these are also provided, and this is also for this condition only. You see here these things are provided by the manufacturer. Again turn on, turn off loss, and your times, turn on and turn off times, these are given, but the set of conditions they change. Over here what you observe is that this is for these conditions are remaining same, but here this junction temperature is 25 degrees C, but here the junction temperature becomes 150 degrees C. Okay. So based on it you can see here that the times are becoming different, your all these turn on, turn off times and losses are also becoming different. Here you can see this total switching losses 4946 microjoules, whereas here it is 3287 microjoules. So your total loss increased with your junction temperature. Further, your input capacitances, output capacitances and reverse transfer capacitances, they are also provided and given in your picofarads. Then this RBSOA, this is defined here that this is full square. Now it may not be full square for all of the IGBTs. There is something called as because of the intrinsic nature or the how the device is designed, there may be a slopy line there in the RBSOA. So here for this IGBT it is not true. So this is a full square, and they have also given the conditions from over here. Then reverse recovery energy of the diode, that is also provided. So these are basically your diode turn off characteristics, your energy associated during the turn off, then reverse recovery time, reverse recovery current, these are all provided. Now you can see that the peak reverse recovery current, it can go up to 34 amperes. This is very significant value, and the conditions of measurements are given over here. Further, this data sheet gives you some performance curves. So you can see here that this is the load current versus your frequency. So this is for which they provided this square wave to these ones, and then they had provided an inductive load, and then they saw what could be the load current. And as you see here that below 1 kilohertz your this load current is can be quite high. After that, as your switching frequency increases, you can see here that there is this load current, it is going to decrease, and the power dissipation they have limited to 95 watts. Junction temperature they are maintaining it at 150 degrees C, heat sink temperature at 90 degrees C, and the duty cycle given was 50%. Okay. So, this is just to give you an idea that what switching frequency you could be choosing for your application. Of course, you may not be having always this 50% duty ratio. Based on this condition, this is what the curve that is provided by the manufacturer. Further here, this is your collector current IC versus case temperature. So, that is going to come down, this derating is going to happen as the temperature increases. Then total power dissipation limit, that is also going to decrease as your temperatures are going to increase. Then these are your SOA curves. So, this one is basically provided by the saturation operation. What is the current limit? You can see here the voltage is very small during that time, and after that this is your current limit of the device, okay, 100 amperes. This is the voltage limit of the device, and then if we apply the pulse for 1 millisecond. So, this is the power dissipation limit PD, and this we had discussed when we discussed SOA. So, these are all power dissipation limits. As your this pulse time decreases, this limit increases, and this is for your DC. So, this is all your safe operating area, the normal SOA or the forward biased SOA, FB SOA, what you can we can tell. Then your RB SOA, reverse biased SOA. So, that is just basically two lines over here, one is the current limit and another is the voltage limit. Further, what you see is the output characteristics. So, which is a graph between your collector current and your collector to emitter voltage, and it changes with your gate to emitter voltage. So, these are all the gate to emitter voltages that are applied, and we can see here that it is above 12 volt is what it goes into saturation, and so we should be applying more than 12 volts. Then further this is given for your minus 40 degrees C. So, this same is given for 25 degrees C, because this output characteristics is changes with your temperature. Then further the same output characteristics is provided for your 150 degrees C. Then this diode forward characteristics, your diode current versus your forward voltage drop across the diode for different temperatures, that is also given by the manufacturer. Then this one is your collector to emitter voltage versus gate emitter voltage, you can see here that as your gate emitter voltage is reducing, it is going into saturation, the IGBT, and so your collector emitter voltage, that is decreasing. And what is the corresponding collector current, that is also given over here. It increases with the collector current, but the overall collector emitter voltage, it decreases greatly when this gate emitter voltage is increased and it goes into saturation, and so, this is given for minus 40 degrees C, and the same is provided for 25 degrees C, how this graph changes with temperature. Further, the same characteristics that we just saw is provided for your maximum junction temperature 150 degrees C. Then this is your forward transconductance. So, this you can see that is between collector current and gate to emitter voltage. So, this is where the collector current starts to increase. So, this is where your threshold voltage is going to be, and these are given for two different temperatures. Then next is these losses with respect to your collector current. So, you can see that this turn on losses they increase with collector current, and turn off losses they also increase with collector current. And the switching times, how they change with collector current, you can see that this TF not much change, delay time it reduces, rise times and your TD on time, delay in on time, these are increasing with your collector current. Then those same energy loss and with respect to gate resistor RG, how they are varying, that is also provided over here. So, both of these for this IGBT, what we see is that the turn on losses and turn off losses they both increase with gate resistor, and this is what we normally expect. And the turn on and turn off times, how they change with your RG. So, turn off delay it increases, TF it somewhat decreases, but not much change, rise time and delay time during on turn on that increases with your RG. Then what we see here is the manufacturer has provided the reverse recovery current versus your forward current IF, means while it was conducting, the diode was conducting, how much current was, and then correspondingly how the reverse recovery current changes. You can see here those are given, and you can see this is in ampere. So, the reverse recovery current over for this diode is quite significant, and for different gate resistor values these are provided over here, and this is for 150 degree C they have provided this. And this is how this IRR changes with the gate resistor, that also has got an effect on IRR, and so that is what is provided by the manufacturer. Then how this reverse recovery current IRR it changes with your di by dt. This we had discussed when we discussed diodes, that these are also associated with the rate of change of current, and so as your dif by dt changes, your reverse recovery current is increasing as this is increasing. Then further it also gives your reverse recovery charge of the diode versus your rate of change of current, and this is further you can see for different resistance values they are provided, and the limits are also given over here. Then these are your diode loss and loss with respect to the diode current, what the diode is going to carry. So, basically these are all diode characteristics that are provided by the manufacturer. Further what you see here is your this capacitance of the IGBTs, the input capacitance, output capacitance and reverse transfer capacitance, how they are changing with your collector to emitter voltage, and this is your gate charge characteristics. This we had discussed how your this gate charge as it increases, how your gate emitter voltage changes. Further your thermal response also will be provided by the manufacturer for the IGBT as well as for the diode. This will not look into it now, but later we will take it up in the course. Then apart from that the manufacturer may also give you different test circuits that they might have used. So, that is what is provided here. Then the manufacturer also has given different waveforms that they observed. So, those results are provided here. You can see that this is all diode reverse recovery waveform, and then turn on loss waveform and turn off loss waveform. This is what the manufacturer has provided. Then usually on the last page of the data sheet you may be given the package information. So, the different dimensions corresponding to the device that are given in the data sheet. Okay. So, like this you can read through different data sheets and then choose the IGBT and with the anti-parallel diode that is suitable for your application. Thank you.